Hi, let's take a look at what happens when unpolarized light strikes a surface at just the right angle, which we call Brewster's angle, and ends up getting polarized. Now, whenever light strikes a surface, there are always two rays that we're going to deal with, a reflected ray and a refracted ray. And the law of reflection says the angle of incidence equals the angle of reflection. And Snell's law says the index of refraction on side 1 times the sine of the incident angle equals the index of refraction on side 2 times the sine of the refracted angle. Polarization happens when there's an angle of 90 degrees between the reflected and the refracted ray. And for that to happen, light has to be incident at an angle of polarization called Brewster's angle. So what we would see then is that unpolarized light, when it reflects off the surface, the polarization axis is going to be parallel to the plane of the surface where that light reflected. Now, at our polarization angle, our incident angle and our reflected angle are always the same. The polarization angle, Brewster's angle. There's a 90-degree angle between our reflected angle and our refracted angle is theta 2. Well, if we do a little bit of simple geometry, right, we have a line. There are 180 degrees of angle in a line. So, to find theta 2 would be 180 degrees minus Brewster's angle minus the 90 degrees between the reflected and refracted angle. Well, that means that theta 2 is going to be 90 degrees minus Brewster's angle. And Snell's law tells me n1 times the sine of Brewster's angle is going to be n2 times the sine of 90 degrees minus Brewster's angle. There's a trig identity there. The sine of 90 minus an angle is exactly the same as the cosine of the angle. So that means then that I could simplify this. If I divide both sides by the cosine, I have the tangent of Brewster's angle. And by dividing both sides by the index of refraction on the initial side, the incident side, the tangent of Brewster's angle is the index of refraction of the material off which the light reflects, divided by the index of refraction of the material in which that reflected light is traveling. So let's look at an example of something you would encounter very often going outside on a sunny day, light reflecting off glass. So glass usually has an index of refraction around 1.50, and air normally has an index of refraction pretty close to 1. So n2 is 1.50, n1 is 1. Now tangent has no limits from a minimum value to an upper value, so I can happily take the inverse tangent of 1.5, and in degrees, Brewster's angle for light reflecting off glass is 56.3 degrees. At that angle of incidence, the reflected light is going to be polarized parallel to the plane of the glass. Thanks for watching.